Boys and girls, we've reached the middle of the second day of High-Load Armenia. 10 minutes ago you heard me mispronouncing the name of Elasticsearch. I said Elastic Church. Okay, we're in Armenia. Anywhere you go, there's a church. But so my talk about a church is done, and now let's talk about Elasticsearch. Igor, пожалуйста.
Oh, that's me. Thank you. Hi, everyone. Can there be a first slide, maybe? Yeah, thank you. So thank you for coming. Today's talk is about how we reduced logs caused by moving from Elasticsearch to Grafana Loki. So the first question I think I have, is there someone familiar with Grafana Loki? Okay. And just to be sure, with Elasticsearch, yeah, much more people. So I hope that I'll tell you something new, maybe about Grafana Loki, and for those who don't know anything about it, we'll learn something useful. Yeah, how am I? My name is Igor, as I said. I'm a co-founder and a system architect at KTS. We have a stand there. I think a lot of you visited us already, so I will not stop on what we do and stuff like that. What we're gonna talk about today? So the three main points will be: we just discuss briefly what is a log collection task. We discuss how Loki is built, talk a little bit about its architecture, compare it to Elasticsearch, where Loki maybe has some benefits, maybe where it has its downsides, and so on. And the main part will be about how about our journey, how we transferred log from Elasticsearch to Loki, and how you can do the same using maybe some of our own knowledge in this topic. And the bonus, we'll talk about it when it comes to it. So what this talk is not, just to be clear, it's not a Loki or Elasticsearch tutorial. It's not a comprehensive comparison of those two tools. There are, I think, a lot of stuff in the internet already. And it's not a complete set of instructions how to transfer logs in your environment, because it all depends on a lot of stuff, I think. So let's talk briefly about log collection problem. Usually you have to answer to four main questions when you're talking about logs: how you collect them, how you extract anything useful from it, how you store those logs, and how to query them. I think the most difficult part is about querying, and it's deeply connected with how you store the logs. And this is the main part where Elasticsearch differs from Grafana Loki. You can have multiple sources where your logs coming from. It could be Kubernetes clusters, Docker containers on the virtual machines, databases, maybe some cloud environments, logs that coming, and you want to analyze them in the future. And usually you have a straightforward pipeline, I guess. You collect those logs, you process them, filter, transfer to the storage, and on the end user you query them. We all know the competitors, I guess. This is not a complete set of technology that you could use for log collection problem. I think the main players are Elastic and Grafana Loki today for the cloud environments, for Kubernetes clusters. ClickHouse has a great promise in that and in storing logs. But yeah, we're gonna talk about the standard de facto, I guess, Elastic for quite some time, and now standard de facto, maybe it's coming to Grafana Loki. So Loki architecture and how it differs. The main difference, I guess, from Elasticsearch is that Grafana Loki has this separation of read paths and write paths. So write paths is on the right. All these components, I guess, are stateless, like the distributor, query frontend, querier. Only the ingester, which communicates with the storage and saves your logs is a stateful like microservice. There are a lot of caches. So Grafana Loki is not an easy instrument to configure, I guess, at first start, but it's a really easy instrument to maintain in the future as compared to Elasticsearch in our experience. Now, this is the main part, I guess. Indexing. When you have a log line, let's say it's just get/about, you have a timestamp. It's surely indexed because when we want to query logs, we want to query them for the certain period of time, and you extract like certain labels from your logs. Maybe you're already sending labeled data to the log storage. Maybe you're extracting labels from the log lines. Let's say log level extraction application is logged into the log line and so on. And Loki indexes only these first two. It doesn't index the log line at all. And why is that? Because I think developers and everyone doesn't want to lose any important information, and if you log as much as you can, you should certainly do that. And when we're talking about Elasticsearch, it indexes every line. It indexes every text that you have in the search, so you can search for it, so you can query the data. And this expands the storage immersively. You have to have really big disks and a lot of RAM and a lot of CPU to process and store those logs in Elasticsearch. Now, diving deeper into the architecture and how Loki works, when you have a unique set of labels, so there are different colors on the slide, they're all called separate streams, and they're stored independently. So every chunk, all log lines are stored in the chunks, but we'll talk about it later. The stream is just a collection of those chunks, so a collection of the log lines. And it would be really important for us later to understand how we transfer the logs. Well, this is the slide about chunks and index. Now, what about how it's stored? Chunk is just a small subset of the log lines. Usually, and by default, it's 1.5 megabytes, and it's of compressed size, and it's just stored as is to the object storage or to any storage you have, and you have to have a separate index, and this index is where Loki can understand what chunks actually refer to the query you're searching for, like the timestamp, the labels. It just selects all the chunks necessary for the query, selects them from the storage, downloads them, and then processes them and gives you the results. Loki actually has a lot of storage, a lot of chunks and index storage solutions, but currently they're moving to this idea that you store chunks and index all in the object storage, all in the S3. They currently have BoltDB Sherper technology for that, so for index, I mean. So it's just a small BoltDB files. Usually index is not very big. For 15 terabytes, I guess, of log data, BoltDB index is just, I guess, 300 megabytes of compressed data. In Loki 2.7, which was released just recently, they introduced new index format, which came from Prometheus. It's called TSDB, and it's even more lowers the amount of space needed for the index. But yeah, essentially the main idea is that you store chunks, all these small parts of data and index in the same object storage, and you access them through the write path and through the read path. Now, when we talk about how we decided to even to transfer to transfer all the logs to the Loki. Why we did that? So we had a client who had really big cluster of Elasticsearch, and was there were two problems actually. First one was a huge money burden, and the second one was really hard maintainability. What do I mean by that? Uh, do I have a... Yeah, this was the cluster of Elasticsearch. Um, it was, I guess, 6 data nodes, several master nodes, coordinator nodes for the different tasks. I think those who are familiar with Elasticsearch understand that. And essentially, this cluster was consuming a lot of money. It was it was consuming a lot of resources like CPU power, RAM usage, and surely disk. I will show the exact numbers later, but yeah, let's stick with that. So how it was built? So there was Elasticsearch cluster, and there were application nodes. On each node, there was a file bit for transferring logs from files, and there was a packet bit which captured traffic from HTTP port. This was extremely important for the client to know exact request and response messages that were coming through the port. And these messages actually were really big, and it was a hassle to make Loki work with these kind of big messages. Migration plan, if I look back now, how it should look like, it is a really big. There are a lot of points that you should achieve. A lot of failure points. Okay, a lot of failures happened during the transferring. But yeah, we're gonna stop on 3 points. First one, we should deploy Loki cluster into Kubernetes. We're not gonna talk about that because it's a fairly simple task. Not so easy task to configure Loki, but on that later. Collecting live logs in Loki, we had to make sure that everything works in parallel. So we still have Elasticsearch cluster. We should have a Grafana Loki cluster. We should see the exact same logs in both clusters to make sure that everything works as expected. And only then we have to transfer all logs for the same, having the same labels that you have in the new logs that coming from the prompt tail, I guess, and the old ones that should have been transferred from the Elasticsearch cluster. Okay, we tried not to break everything, as I said. We're running everything in parallel. We spin up prompt tail that was transferring logs to Loki. We still had file bit and packet bit transferring logs to Elasticsearch, and we had to run a separate packet bit parallel service, we called it, which saved logs into the file, and prompt tail had those files coming to Loki. We even started collecting logs from systems that were not having logs before in Elasticsearch, because Elasticsearch consumed a lot of disk data, and yeah, it was not worth it to have all those logs before, but now it is. It's a simple config for prompt tail. I think I'm gonna stop on that. We have extracted labels necessary for that kind of application. We had an app label for the service that was running, and any other information that was okay. How we decided what labels to extract, you ask? Because when you have logs in Elasticsearch, essentially you can query on almost all fields. Every field is indexed if you don't specify otherwise. In Loki, you don't have such opportunity, and so you have to really decide what are your usual queries that you have, and only then decide what kind of labels to extract to make sure your logs querying works fast. And the same was for the packet bit. We extracted like HTTP status, HTTP method, stuff like that. Now the main part. So we have set up the infrastructure to transfer new logs. Now the main problem: how to transfer the old ones. What concerned us? There was a 1-year log of data. It was really important to have all that information for the compliance reasons, for the security reasons. So it was really necessary to maybe know what happened in January 2021 with the specific user. It was not a big amount, not really a big amount of storage. It was just 25 terabytes. But we really wanted to transfer those logs as fast as we could, and we decided that we can maybe fool Loki into accepting all those logs as fast as it can. So let's talk about that. Our initial assumption, we thought if we have a whole year, like from January to December, let's divide all this the whole year into small intervals and transfer them absolutely in parallel. So we extract the same set of labels, apply them to the log lines for these specific intervals, and send them in parallel as Loki. We will increase every timeout we have. We will increase every ingestion rate limits, but we want to do it as fast as we could. So this was our transfer utility that we started to build. It was transferring log in parallel. So it had you spin up a process, specify from date and to date, and then just process the logs and send them to Loki. But yeah, we increased a lot of limits. We increased ingestion rate, increased burst size. And the main thing, I guess, here is this setting reject all samples. You have to turn this off when you want to accept the log lines that happened before now. Not before now, but before the last log line that already exists in the Loki cluster. And this is actually now because we are transferring new log lines already. And the retention period, we had to make sure that no logs would be just deleted when we transfer them into the cluster. But as soon as we start to do that, we get an error which states like this: entry too far behind, all this acceptable timestamp is some date in the future. So why was that happening? We started to dig into the code. You can see on the link when you have the slides. Essentially, it's happening here on this line, and the reason is that formula, like highest timestamp minus chunk age divided by 2. So this was a real. We didn't quite understand how max chunk age can be. How this whole process of transferring logs can depend on the age of the chunk. So what is the max chunk age actually? It's the amount of time the chunk lives in the memory while you transfer logs to it, and just the maximum age. So it's just usually 1 hour or 2 hours. Well, I'll explain what it means for us. We have those parallel intervals, different colors. And let's say we accepted already timestamp 100, 101. In parallel, we send timestamp with 210 and then in 350. What will happen when the interval 1 sends new timestamp, which is 102? We're still sending some January logs, I guess. And it will get rejected. Because let's say max chunk age, like maybe 50 in here, in these dimensions. And of course, the highest timestamp is 350. 350 minus 25 is still 325, and this log line would get rejected. How to fix that? Well, we see the code, we see the formula. Let's increase the the item that is bothering us. Let's make it the whole year. Well, now this when you do that, you actually get results. You think that you fixed everything. You just accept it. Loki just accepts this silently. And we thought, did we fool actually Loki into something it shouldn't be doing? Oh, turns out not really. On the ingestion part, everything goes fine. We transfer logs extremely fast. We can split them in as many intervals as we decide, I guess. But the problem happens when we try to query those logs that entered the system through this hack, I guess. We start receiving a lot of errors, like bad gateway errors. A lot of systems started to fail. I think query error is just error from querier. The bottom error is error from the Nginx server's proxy. Too many unhealthy instances in the rings is just a sign that everything just broke when we did that. So what was happening? Let's try to investigate. There are a lot of issues on GitHub about this 502 error, bad gateway error, but actually we had a lot of communication in the Grafana Loki Slack chat, in the issues, but as you may guess, nothing really works. Nothing really helped us. So we decided that it's time to dig in even more into the source code and start just thinking. Now, the first thing when you want to understand what is happening, you have to actually dive at the bottom, how everything is stored in the Loki. On the right-hand side, there is a chunk. Yeah, this is the structure of the chunk. It's just a separation of bytes. The main thing that I want to emphasize here is that yeah, block is just a set of log lines. It's stored in the chunk, and you have for each block you have minimum timestamp and maximum timestamp that this block holds. So what? Let's start investigate even deeper. There is some source code. You don't have to actually understand what's happening there. We append the log line to chunk. We append the log line to the current head block, which is a current block that accepts the log lines. And what is happening on the unordered head block, which accepts the writes when you have reject samples, all samples false? It just updates the boundaries, actually. So it appends the log line to the block, updates the boundaries if necessary, and then just saves it. So it doesn't reject anything, or so that was the case. We didn't receive any errors. So yeah, so what? Let's try to see how the head block looks like when we have that diagram on the left. It's pretty obvious. We have all these 5 log lines with different timestamps, and the minimum timestamp is 100, maximum timestamp is 350. Nothing criminal, actually. It's not sorted. Maybe it is sorted later. We didn't have to know about that. But what happens next? We save a chunk with these blocks that were populated with this parallel ingestion of log lines. So we have block 1 with interval 100 through 50. We have a second block maybe with interval 104 and 360, and so on. So if you can see that all the chunks, they really have blocks that are really intersected with each other. So a lot of blocks. So if you try to query logs in interval 120 and 200, almost all the blocks correspond to this interval. So what does it mean for us? So we have these small chunks that are stored in the object storage that contain our log lines in the blocks. And these blocks are described with these intervals, like minimum timestamp, maximum timestamp. And they all intersect with each other. And essentially, Loki is forced, when you try to query the logs in the interval 120 to 100, Loki is forced to download almost all the chunks from the storage. And what does it mean? You will never have memory for the querier to have all the chunks downloaded. So essentially, if you have 5 terabytes of log data, which we had, Loki had to download all those 5 terabytes into the memory, and then just it gets killed essentially. And this is where 502 errors come from. Queries just died, and yeah, we didn't receive any log lines. So essentially, the problem was not with the querying part. Querying worked perfectly fine when we tried to search for the logs that were transferred by the prompt tail for the new log lines. But the log lines that we transferred using our utility just didn't work. So how to fix everything? Well, we still had to transfer logs. One possible solution is to transfer all the logs sequentially. You start from the 1st of January all the way up to 31st of December. Transfer them log line by log line, no parallelism, and only then you enable transferring new log lines. So you will never have a log line. So you will never have a timestamp that is bigger than the timestamp of the entry that you're transferring. That's the first option. We didn't have that option. Well, the second option, I guess, is just wait a whole year when all the log lines from the Elasticsearch get the transfer to this state where we don't need them anymore. But yeah, we have to wait the whole year for that. That's not acceptable. Oh, sorry. So we have the third option is to remember what the stream is. So the stream is the unique set of labels, and all the limits like ingestion rates, megabytes, all these errors about entries too far behind is all connected to the stream, and not all the log lines that you're transferring to the Loki. So what does it mean for us? Well, first, don't set max chunk age to high value, because it's just gonna break the insertion and ingestion part. All the blocks get mixed up, all the chunks get mixed up, and in the result, you query a lot of data that you don't have to query. Don't send logs in parallel for the same set of labels. This is the most important part. You have a stream, you have a unique set of labels. Only send unique streams in parallel. You can do that. And how to do that? How to do that when you have the same exact set of labels for the logs, like new ones and the old ones? You can just add more labels. And essentially that is what we did. When you're transferring on the preprocessing part, we added just a small label, like what interval we're transferring. And actually that was the simplest solution that you can achieve. Yeah, but that was it. When we tried to query logs, and this time, all the blocks have the data in them that is not intersected. So when you try to query logs from 120 to 200, only some subset of blocks get matched to the query. And the query just need to download a small subset of chunks, and that works really fast. Now, what's happening with the chunk situation? Once again, query matches less chunks. All blocks with all chunks are strict loaded. That's also an important part. And we get fast and efficient query execution. Now let's talk about a little about transfer implementation, how we did that. It's a really simple, I guess, solution. We have a component which is called Elasticsearch Scroller, and this was the real. Was not easy as well, because Elasticsearch can return a lot of errors depending on what exactly happened. And there was once a situation when Elasticsearch didn't return any errors. We started to transfer all those logs, but it has occurred that there was an error, not maybe an error, a warning that not all shards of Elasticsearch return the data. And essentially it meant that there is still some data relevant to the query that we're searching in the Elasticsearch that wasn't returned just for us. So the main part here on the bottom, always wait for error resolution, because we cannot lose log lines. We cannot insert them afterwards. We have to do it one log line by log line. So yeah, that was the main idea of this Elasticsearch scroller. When then you have logs processor. It just extracts the labels, very similar to what Promptail does. It saves the positions so you can restart the whole transfer utility and then send them to Loki. Well, we tried to do, as I said, as fast as we could, and we tried to do it in parallel here again. Well, we failed, of course. So you have, so this is the logs processor. So it extracts labels. This is what it looks like. Yeah, we'll talk about just in a second. So Loki sender, what it did, it sent data to push API of Loki and send data sequentially. So this is the main part. Don't try to full Loki as we did. Only send logs as much sequential as you can, because you cannot go back and insert logs that were happening before. Only if you create a separate stream, but it's not very convenient sometimes. We had support for different protocols. For transferring log, we tried JSON, we tried JSON plus xzip, we tried protobuf, protobuf plus snappy. Essentially, protobuf plus snappy is the default, and it is the fastest, and it is the fastest way, and it has the smallest chunks possible. Essentially, what I want to say that you can already use it. We have a utility. It's called ES2Loki. You can find it on GitHub. And this is the QR code. What is it actually? So, sorry. Essentially, it looks like a library, but essentially every possibility that we had where we can fail in transferring logs, in receiving them from Elasticsearch, and transferring them to Loki, we already did that in this library. And all you have to do is just extract your labels in some Python code, but this is all the code you have to write. You extract the labels that came from this source dictionary. This is the Elasticsearch document. Extract the labels, and you're ready to go. You just spin this up, and we'll transfer your logs consistently and in safe manner. We also have a Helm chart for that. So you can specify even your own image. You can build anything unusual, maybe how you extract the log lines from the Elasticsearch. So you can do whatever you want. Just specify your image, and you're ready to go. There is also a demo folder in this repository. You can spin up all the components. You can spin up in just one command, like Elasticsearch, Kibana, Grafana Loki, Promptail. FileBit will transfer quote old log lines, and the Promptail will transfer new log lines into Loki. And this Docker Compose will spin up ES2Loki and transfer all the old log lines from Elasticsearch to Grafana Loki, and you can just see it in Grafana for yourself, that all log lines are already there. Did we have any profit? You would ask. The title of the presentation was how we saved the costs, right? This is what Loki looks like in Kubernetes. A whole bunch of microservices, 19 microservices, much more than we had in Elasticsearch. But the main idea is that Loki is much more simple in maintaining. It has very straightforward paths where you can optimize things. If you want to optimize your ingestion part, you take a look at distributors and ingesters. If you want to optimize the read path, you just increase the number of queries as much as you want. and your log lines would be, all your queries would be split into small intervals and deliver your logs as fast as possible. So yeah, this is the comparison of architectures. And actually, there was a paper, not a paper, an article on the Elasticsearch blog that they suggested that they are developing a new stateless architecture for storing stuff, and it's very similar to what Grafana Loki has. It's on the bottom, so essentially doing the same thing. So it's really interesting to see how it all goes, how these instruments would be compared to each other, but currently this is not available yet. So yeah, let's compare the infrastructure. This is what we had in Elasticsearch, 44 CPUs, 200 gigabytes of RAM, and 25 terabytes of main storage. It all came down to just 5 terabytes of S3 storage and much less CPU power and much less RAM usage. So this was a real huge money saving for the client. We reduced like infrastructure cost in 4 times, I guess. There are no exact numbers here, of course, but yeah, it was almost 5 times. But we unfortunately had to use faster disks for S3 storage, but still, it was a huge saving. Let's do a little recap. What were the results? As I said, it was 4 times logs infrastructure cost reduction. So if you have a lot of logs in your Elasticsearch cluster and you don't do anything unusual, like maybe machine learning, or so yeah, every case is different. But yeah, if you really want to try Loki, this is the great opportunity for you to save money, save a lot of money actually on your infrastructure. Essentially, this is not also 5 times reduction because we started to collect even more logs. So these 5 terabytes, it's not just 25 to 5. It's just 25 to some number, and then we added even more logs from different services, from different environments, and we achieved 5 terabytes of storage. Loki has much simpler infrastructure maintenance. We had a lot of problems with Elasticsearch. I guess a lot of you guys also do have and understand that. It's much more stable installation, I guess. Logs transfer happened for us in about, I guess, 3 months. So we transferred the whole year of production log lines and the half of year of test log lines into Loki in 3 months. Yeah, as I said, it's easier to scale. Not so positive, but okay. We needed to use much faster disks for S3 storage. We used Min.io to set up S3 storage as we didn't have a possibility to use any cloud environment. Grafana in no way currently is Kibana, so if you're really dependent on how Kibana displays your logs, you can try Grafana, and if it seriously doesn't work for you, maybe you have to stick with Elasticsearch a little more when Grafana has more possibilities for you. There is no full text search, but this is like core principle. You just full scan all your log lines and find the necessary logs that match your query. No machine learning, as I said. Some queries in Loki can be slower than in Elasticsearch. This is due to the fact that there is no full text actually. So you have to full scan all the logs, but it's an okay performance, I guess. For the short-term period logs, Loki works really fast, and it is really compared to Elasticsearch. Maybe sometimes it's faster, maybe not, but it's still okay intervals. If we consider bigger intervals, like let's say find a log line in the whole year, this is where Elasticsearch may be faster, but actually we don't we have enough time to wait, I guess, for the logs to be processed when we talking about find something in the whole year. So that was an okay solution for us. Actually, that's it. Not exactly, but I had a separate section on the Loki configuration checklist where I would describe some parameters that we tweaked that really helped us to gain as much performance as we could. But yesterday there was a webinar from Grafana Loki, and I really invite you to look at it because it has all the tips and all the necessary information that we really needed when we transferred logs, when we set up Grafana Loki. Yeah, this is the QR, this is the link. I really recommend watching. It's just 1 hour and a lot of useful information on how to exactly run Loki and how to configure it properly in different environments. Yeah, that's almost the end. We have, as I said, we have a stand here in the hall, and we'll have a brief discussion of MLOps. So if you're interested in that, you can visit us at 15:30. And that's it. So I'm really glad that you joined me today. This is my social links. And yeah, please rate the talk. Thank you, and to your questions.
Thank you, Igor. Questions? So 2 questions over there, 1 over here, 1 on the first row. The next talk is in 30 minutes, so we'll just answer the questions. Please.
Thank you for the talk. Can you say, is the performance of Grafana Loki depends somehow on how many data, I mean, how long data for 1 year, for several years are we stored?
Yeah, essentially, Grafana Loki is not dependent on how much data you have. It is dependent on how much data you want to query. So as I said, if you want to query the whole year, that's gonna be a little slower, but you can throw as many queries as you want. So this is the read path microservices. And you can split those. If you have a whole year, maybe you can spin up like 100 queries, set up, I guess, a small cluster for that, spin up 100 queries, attach them to this S3 bucket, and they're gonna split the query into smaller intervals and extract the log lines much faster. And what is really Loki depends on is the storage underneath. So it really depends on how fast is the S3 storage. So this is why we had to use faster disks in S3 as well.
If I stored in S3, can I move some old logs to Glacier or some other cheaper storage?
Actually, we in KTS, when we spin up like Loki clusters for the clients and for ourselves, actually we store all the whole buckets where we store this. It is a cold storage already. So the performance of that storage is enough for us to query the logs. And I guess, so I cannot answer straight, right? There is a possibility to split all the logs into multiple buckets, but it happens evenly. So I think you cannot move really log lines to the cold storage for now. Maybe this will happen. I think there is an issue on Grafana Loki issues on GitHub. So yeah, I guess that's it.
Okay, thank you.
Hi. I probably missed some part from the talk, so question could be quite stupid, but I couldn't understand why you even need like parallel ingestion to move your old logs from the past year. Like, why do you need to parallelize this process? You don't have like huge amount of logs, and 25 terabytes, I mean, could be moved in linear fashion, right?
Well, our 25 terabytes have been moved in parallel in 3 months. So you can understand that when you talk about sequential transferring, that will be much more. That would take much more time. But the main reason was that our clients said. So when we first met this client, we said, well, you have a huge cluster of Elasticsearch. You're using it only for logs. We have experience in Loki. Let's cut down your costs. It will be 4 or 5 times reduction in your costs. And he thought, well, let's do it right now. I cannot wait anymore. So essentially, that was our problem, that we stated that we can transfer logs as fast as we can, and we had to do it as fast as we could. But the main point I want to emphasize here, oh, I forgot what I wanted to say. So you're asking?
I'm asking about why do you need a parallel process when you could have a sequential. I got that, yeah, you had a migration in 3 months, so in sequential it will be much longer. But what was the bottleneck of that process? Is it because you had to move data across data centers or something? Like, could you attach, I don't know, disks in the same data center to move it faster, attach SSD disk to move it faster, or it will be some kind of different bottleneck?
Well, you can't just transfer logs, just take them from Elasticsearch and insert them somehow in Loki. There's different systems. So you have 2 bottlenecks. You have Elasticsearch bottleneck when we transfer the logs from it. And we cannot load it as much as we can, because users still use the Kibana, still use this Elasticsearch to query those logs, to query those 1-year logs, to process the whole amount of logs. We have to do it like in slow motion, I guess. And on the other hand, we had Loki, which was not accepting as much data as we can ingest. We also had to have this balance of how much infrastructure we spin up just to transfer the logs, and yeah, not balance, but we had to make sure that we don't consume a lot of infrastructure just for the transferring. So it was a real balance.
Got it. Thank you.
What about hello?
Sorry, where? Okay.
Okay. What about multi-line logs for Promtail? How correctly it Promtail handle multi-line logs when we have one line with timeline and secondary line, for example, stack traces?
By default, actually, Promtail handles it pretty good for the log lines that it understands pretty well. So we have like Python applications there that are running, and if you're familiar with Python traces, they're all transferred correctly. No need to configure anything. But if you have something different that differs from, I guess, what Loki understands already, you can, in Promtail configuration, you can specify a regular expression where the log line, multi-log line starts and when it ends. So Promtail can understand that and extract information.
Okay, do you collect logs with Promtail from Kubernetes system components like Blade? Yes, то есть, okay, it means you collect the whole logs, the whole Kubernetes cluster, not the only application level.
Yes, all the logs that are coming. So we had different sources. We had the Kubernetes cluster as the source of this infrastructure of Loki, and there was a monitoring solution. So a lot of infrastructure stuff was deployed in this cluster. We collect the logs from them, and the exact application or all the microservices were running on different set of servers infrastructure, and yeah, we had the Promtail which collected logs from the log files and transferred to the same we split those, if you're really interested, we split those logs into different tenants so they don't intersect in any manner.
Thank you for your speech. Oh, okay. Thank you for your speech. I have many questions, but ask it only two. One of question is how many labels do you have? Because I know best practice in Loki, you can manage labels only 10 or maybe 12, because if bigger, Loki is overloaded and you have a bad gateway. How many labels do you have?
Okay, answer that. Loki is really close to infrastructure and how it works and stores the data underneath to Prometheus. So the same problem occurs actually in Prometheus. You cannot have millions of labels. Well, you can, but you should scale properly. Essentially, there is no limit, I guess, for the labels. There is a limit. You can turn this off. But the main thing that you have to concern when you're using Loki is to not have a high cardinality for the labels. So you have to have a finite amount of label values. So you cannot label like request ID maybe or user ID, because this is an indefinite set of values.
It's a dynamic label, dynamic values in labels.
Dynamic values in the same, which goes with the Prometheus. You cannot have the same in there as well. So the performance would drastically degrade, and this is essentially because of the underlying storage infrastructure, because of the streams. Because when you add additional value to the label, you receive a different stream, and you actually splitting this the same log lines into millions of streams, which queries have to download them all, and this just degrades the performance. So the main point is to have low cardinality for the label values, and in terms of labels, I think you can have as much as you want.
Okay. Second question about Grafana Loki as dashboard Explore tab. For me, about 1 year ago, when you give a Grafana Loki Explorer tab for logs, you have problem with your browser when more than 1,000 lines. When it's low amount information for developers, because he needs 5,000 or 10,000 lines, and Chrome browser it's take amount of memory. How you use the switch in Grafana Loki?
Yeah, there are two ways. The first one is let me see. You're talking about the limit that limits the amount of logs that are returned to Grafana into the Explorer tab. Well, the first, you can increase this limit in Grafana settings, but essentially when you increase it like to the huge amounts, like 500 lines, 1,000 lines, 5,000 lines, are you sure you're gonna look through all those 5,000 lines in? Okay, you have an opportunity to filter those log lines. Why not do that? So why not find exact lines that you really need? But this is the first one. So essentially, the answer to that is to add more labels to filter the data, or just pipe and search for the string in the data, and you can find the context between the log line that surrounds this log line. So there are a lot of ways to find the exact information. The second point that I want to make is that there is a log CLI tool from Grafana Loki, and it connects to Loki cluster, and you can download all the logs directly from Grafana Loki without Grafana itself. So essentially, this is the way that we did it. You have log CLI, you have a query that queries logs somehow, and you just pipe it in bash to like grep or Perl or something that filters log even more, or just saves them into disk on your device and just analyze them later.
Thank you. And let's take the final question and then move to the discussion zone.
Thank you for your speech again. So the main problem you were talking about in your speech is ingesting old logs simultaneously. And we all have some problems, sometimes problems in our infrastructures. And let's imagine that a few nodes with Promtail go down and in different times, and then they simultaneously come back. So what happens is a few Promtail instances start simultaneously sending old logs, and they may contain same streams. So do we face the same problem you faced when migrating from Elasticsearch, and what do you do with that?
Okay, yeah. Yes, you faced with the same exact problem. But essentially the main idea is that you can face with that. So there is a setting reject old samples. You turn this off, of course. So when Promtail dies, it just arrives again and sends these log lines to Loki. And there is a different settings which is called the maximum age of these logs that can be transferred. When we're talking about transferring the logs that happened before, so you can still do that. You should be. The main idea is that you should really watch for your Promtails, that they don't really go out. But still, if you happen to have this kind of situation, and you have a whole cluster did go down, there was one Promtail that was still sending logs and moving this highest timestamp further and further. I think the main solution that comes to my head is just add label to the new log lines and just send them with that. That will create new stream, and you can just move all your logs that were missing before.
Sort of a workaround. Thank you.
All right. So now you need to pick who of the last
I forgot to think
who of the
about
last
that.
guys who asked the question get a hat.
What were the questions?
You were talking about programming something.
Yeah. Yeah. Okay.
Yeah.
I really like the question about the Grafana limits. Oh yeah. I can. Can I?
Yes, you can.
Yeah. That's for you. I really like the questions. Thank you.
Okay. So the hat goes to the right part of the
Gentleman in the white. Okay.
hall. The others can go to the stand and get some more merch. So 2:40 is the next talk here. Igor, thank you very much. So we're inviting you to the discussion zone for more conversations. Have a great evening, everyone.